Okay. Okay, what we're going to do now is something called exact value. I'm going to write down here so we don't forget. We get cosine, sine. Okay? Now, a lot of you watching this will have already done sine, cosine, tangent, like in SOHCAHTOA, like in geometry. This will be a little bit different. This is kind of more like where it was invented, kind of the origins of it. Okay? Here we go. To start off, let's just make sure we know this one thing. Hopefully you're familiar with your special triangles. Okay? We get 30, we get 60, we get 1, 1/2, √3 over 2. I think I actually did another video on this. If you need help, I don't even know what I had for breakfast, but I mean, I'm pretty sure I did a video on that. And we'll have one more special triangle here. 45, 45. For the purposes of this, we'll have this one, we'll have this √2 over 2, and this will be √2 over 2 also. Okay? Now this is not that hard to understand. It just takes a minute to practice. Let's start off by saying we start off with a 30-degree rotation. We already know that's going to be pi6. You watched that from the other video, and I'm sure you memorized it, and it was just wonderful for you. But what I'm going to ask you now is, what is the sine and cosine of 30 degrees, or of pi6, one or the other? Remember, they're kind of equivalent ways to describe a rotation. Okay? So we're going to start off like this. Well, if you look right here with this special triangle, the sine, you can see, represents your y value. Well, from here to here, I went up 1/2. Okay? So my sine of 30 degrees, or of pi6, is equal to 1/2. If I ask you for my cosine of 30 degrees, well, my cosine represents my x, right? How far I went over left or right from the origin. This is going to be √3 over 2. Okay? My cosine of 30 degrees is going to be √3 over 2. These are ordered pairs on the unit circle. What we're really tracking, pretend this is like a minute hand on a clock. As this travels along the unit circle, we're finding out the ordered pair, the location, where it's hitting the circumference of that circle. Radius of 1, 1, 1, 1, right? Where it hits. Okay? As we go further, we're going to go up 45 degrees. We'll do this one in pink, okay? I know it's kind of messy, but if you watch me do it, it's not that bad. This is going to be 1. We already know this is √2 over 2, as I said, right? This is √2 over 2. I know it's messy. So right here, if I ask you for the sine, the up and down of 45 degrees, we're going to write √2 over 2. If I ask you for the cosine of 45 degrees, what we're going to do, √2 over 2. Okay? Not so bad, huh? Now, in blue, I know it's messy. If this extended out 60 degrees, okay? I know it's too messy to write over it. I'll do it kind of right here. Picture this triangle also right here, okay? Get what I'm doing here? Okay, so if this went out 60 degrees, this would be 1. This would be √3 over 2. And this would be 1/2 now, right? So as this went up to 60 degrees, this is now the long side of this special triangle. So if I asked you, that's right there, if I ask you for the sine of 60 degrees, we're going to say it's √3 over 2. And if I ask you for the cosine is x, right, of 60 degrees, how far did it go out? It went out 1/2. Okay? Now there are tricks we can do later on, but right now, just for this, little introduction to exact values and sine, cosine, boom, this quadrant 1. Okay, I can certainly make another video if anyone wants me to later about reflecting over different ways to find all the values around for the stopping points. But right now we're good. If you can figure out the sign of 30, 45, and 60 with these exact values, you are doing very well. Okay? Good. Good job.